In today's video, we're going to talk about something really important in the world of software, boundaries. Now, when we say boundary, what do we mean? Well, think of it like this. Imagine that you have a field, and to know where your neighbor's field ends and your field begins, you draw a line in the dirt. That line is your boundary. This is the first of a series of 3 videos, which we will be diving deep into the world of boundaries. Firstly, we cover the fundamental concepts about boundaries. In the next video, we'll provide a real-world example of a coupled architecture in TypeScript. In the third video, we'll fix the issues from the second video using boundaries. So be sure to subscribe to this channel, and if you have any questions, feel free to ask. So, setting boundaries in software is really just about keeping things organized. And that's why boundaries are so important in the software development, because they help keep things organized and prevent one part of the system from messing with another part. So listen, the primary goal of defining boundaries is to create modular components. These components encapsulate specific functionalities, making our code easier to understand and maintain. Oh my gosh. And why is this important? It's all about minimizing technical complexity. It's what makes our code difficult to manage and change over time. So, what exactly increases technical complexity? One big factor is coupling.
Coupling is how closely connected software modules or components are to each other.
When modules are coupled, changes in one part of the code can have unexpected effects on other parts. Have you ever seen this before? This makes your system fragile and hard to maintain. But when you have clear boundaries between your components, you can reduce this coupling and make your code more flexible and resilient. So let's talk about one of the most common types of coupling we see in software development: database coupling. This happens when our code is very integrated with a specific database system. Any changes to the database schema of technology can have side effects through the entire system. Let me show you an example of a database coupling design. So imagine you need to implement a create user case for any reason. I know this is a very simple use case, but don't underestimate what I'll show here, okay? So what people often do is, let's put our database down here. Then let's create our user model with some properties like user ID and age. Okay. And now let's create our user case. User use case with execute method. Perfect. And what is the flow? Like this, right? Let's recap some concepts. What is a user case? In summary, a user case has built-in roles to process something in the system. So our user case will first take an input, then validate the built-in rules, after that persist data, and then return an output. Let's talk about the user model for a moment. We're using SQLite to handle our database because by using SQLite, we can create these things called models. These things represent our database tables. So when we say user model, we are basically talking about the objects that SQLite use to work with the user table in our database. So guys, can you identify what is the problem with this architecture here? Let's talk about the first problem, okay? This architecture creates a strong coupling between the model and the use case component. Okay, why? The user model has database and business logic. Perhaps you think this makes sense, but you shouldn't. Okay, for example, if you change a field's name, for example, from age to birth date, and the user case, and if the user case is using this field, we'll need to change here also. Okay, this is a coupling. Okay, guys, pay attention here because this is very important. Okay, why does something about the database impact the business rules? Huh? Why does something about the database impact the use case? That's why you need to split the user model into two components. We need to create a user entity. User entity here. Okay. Why? Because they have different needs. Over time, they change for very different reasons. And if you are familiar with Solid, this user model here violates the single responsibility principle. So we need to connect our user case to the entity here. Okay. Our user case, you not use the user model. Our user case, you use the user entity. Okay. But you'll see in the next videos. Okay. Let's come back. Yeah. So let's talk about the second problem. Once we are directly importing the user model, we are coupling our user case with SQLize. Imagine you are change how we save our data. Like we use it to save it using MySQL, but now we want to save it using an in-memory database, for example. But if Oracle doesn't have interface or boundaries, this change isn't going to be easy. In this architecture, we need to add a lot of unnecessary data and many conditional statements to switch from MySQL to an in-memory database. But in the next video, we will learn a better way to handle this kind of situation. Okay, let's talk about the third problem now. So by using this architecture, it's very difficult to write unit tests. And at some point, it will take more time for us to understand and mock away the dependencies than actually write test code. And as you know, a complex test setup is the first step to not having tests at all, because we don't have time for them, right? So guys, in the next video, we implement from scratch this architecture using Node, TypeScript, and Jest. And in the third video, you'll see how to fix everything by using boundaries between our components. So don't forget to like, share, and subscribe for more content like this. I hope to see you in the next one.